Go. Right, question 9. Sketch. 2x squared minus x minus 6. The little bit of working out underneath. Remember we had a space to draw it, and then you had some working out space underneath. That was to do the working out that you need for this. So if we're going to do this, what we need is we need to know where it crosses the axes. Y equals 2x squared minus x minus 6. That factorises. Again, you don't try and complete the square or anything like that. You can just factorise this. It's quite an easy one to factorise, isn't it? 2x and x. And then we have to have what we need, a 3 and 2 probably. It would need to be a minus, is that a minus 3 and a plus? No, it must be, sorry, plus 3 and minus 2 there and there. If in doubt, do that thing when we multiply first and last things together to get 12 minus 12x squared minus 12x squared. That must be minus 4x plus 3x, so do your whole, work it all out. So we get this crosses, and x is minus 3 over 2, and x is 2. Also, we need to know where it crosses the other axis. If x equals 0, y equals minus 6. It's a positive x squared coefficient quadratic. So when I come to draw this, I'm going to mark it at minus 3 over 2, at plus 2. Notice that the axis isn't on the line of symmetry. So my minimum point must be to the right of the axis. So it's going to be a graph that looks like that. We want to get it as symmetrical as we can. That's minus 6. This minimum point must be to the right of the y-axis. That would probably do the job. It's not superbly symmetrical, but it's good enough. That graph. You didn't need to mark any other points on it. What you were getting your 3 marks for here, 5 marks, sorry, was some evidence that you'd found the roots, a method to find the roots, and the roots themselves. So that's 2 marks. A symmetrical, nicely shaped quadratic curve. That gives you 3 marks. It needs to cross at minus 6. There's mark number 4. And the 5th mark is for it all looking really nice, and for the minimum point being to the right of the y-axis. Quite a few of you had a minimum point of 0, minus 6 on there, and lost the final mark for that minimum point not being quite right. If anybody wants to query the marks they're giving me for that, I'll check it in a moment. Part 2. When is it a decreasing function? Well, this graph has 2 parts, doesn't it?
That's right.
As it's doing this bit, it's decreasing all the way down to that minimum point, and from that minimum point onwards, it's now increasing again, isn't it, over that bit there. So we want to know where is that bit there that separates it from being decreasing and increasing. In other words, we want to know when is dy by dx negative. That's what a decreasing curve has. You didn't have to do it this way. You could just find the vertex by completing the square. But that would be, what was the equation? 4x minus 1 has to be negative. So 4x less than 1, so x less than a quarter. That point there is at a quarter. For 3 marks. And now, part 3, it gets really interesting. The line y equals 4 meets it at the point 2x squared minus x minus 6. Calculate the distance PQ. Okay? So this is, you wouldn't draw it on your graph, but this is where, what have I just done there? We want a line across there and y equals 4 meeting this curve, and we want to find where it meets it so we can find the length of that line between those 2 points. That's basically all we're doing. So, for part 3, we want to know when does the line y equals 4 meet the line y equals 2x squared minus x minus 6. Simultaneous equations. We're going to have a sandwich and sub y. Thanks. To get 4 is 2x squared minus x minus 6. In other words, 0 is 2x squared minus x minus 10. As always, maybe worth trying to see if we can factorise it first. 2 times minus 10 is minus 20. Can we think of two things that times to give minus 20 and are only minus 1 apart? Well, yes we can. Minus 5x and 4x would work. So we've got 2x squared minus 5x plus 4x minus 10. Which gives us that. So it factorises as x plus 2, 2x minus 5. So the x values are minus 2 and 5 over 2. These are simultaneous equations. Remember, when we do this, we would have to go back and find the y value. But this is easy, isn't it? The y value, y is equal to 4, no matter what x is. So these 2 points, the y value is equal to 4. Now you could now go into your whole length of a straight line stuff. But actually this is easier than that, isn't it? All we've got, if we think about what we're doing, is a straight line where that's the point minus 2, 4, and that's the point 2.5, 4. And I want to know what that distance is. Well, it's just 5 over 2 and 2. It's a length of 4.5. That's it. That's all we need to do on 9 over 2. If you've done Pythagoras theorem, the square root of the change in x squared plus the change in y squared, the change in y is 0, so you end up with 0. So you end up with this anyway, 4.5. There were a few people who did brilliantly all of this stuff and then forgot to find the length of the line at the end of it. The question said, calculate the distance PQ. But a few people did fantastic at finding P and Q and then forgot to finish it off. There we go.